So this is going over the FIP quiz 2. Number 1 ended up being a little bit of a trick question, and so there were 2 correct answers for it because I wrote it badly. I screwed it up. If we look at ionization energy and trends, the question says ionization generally increases down a group. Well, no, that's wrong. It doesn't. Across or up a group? Well, yeah, if it decreases down a group, it increases up a group, so B is correct. But it also increases across a period. So B and C were correct. So you got credit for choosing either of them. Nobody was daring it outside the box enough to just circle them both and say, but anyway. For number 2 and 3, this is where this gets a little bit tougher because it's very easy when you're looking at these things sort of in isolation, and I give you a period, and I give you 5 elements out of it, and I say, put them in order of increasing ionization energy, and you can all do it like that. When I make you compare across the period and the group, it gets a little bit tougher. So let's walk through those together. So number 2, we're talking about bromine, and you want to know which of the following atoms would have a smaller radius than bromine. And so to compare these, you want to look at each of them sort of case by case. So you've got chlorine, you've got potassium, you have iodine, and you have krypton. So in every case, you're comparing above and below it in the group, and you're comparing left and right in the period. So if we start from the back and we start with krypton, well, we know that atomic radius decreases, so radius goes down as we go this way. So we know that krypton is going to have a smaller radius than bromine, yeah? So this is for number 2. Yep. Whoops, my mistake. Let's get rid of all the drawing associated with krypton. Okay, you had arsenic to compare. Whoops. Okay, well, we know that radius decreases as we go this way. Yeah, actually, krypton would have a smaller radius than bromine. Duh. And so both arsenic and potassium are going to have smaller radii than bromine because the radius shrinks as we go towards the noble gases. So then if we compare in the period, we know that radius tends to increase as we go down. So we would expect that iodine would have a larger radius than bromine. So it's not iodine, and so that means it's chlorine. And for questions like that, that's really kind of what you have to do is compare each of them, like, oh, okay, well, within the group, which direction would it change? Across the period, which direction would it change? So then for the next question we had, and I'll use other colors here. I'll go with blue. For the next question, we want to know which of the following would you predict to have a larger radius than potassium? And we're given cesium, lithium, so comparing within the group, and we're given zinc and krypton. That's where I got my krypton from. So we're looking at larger radius, and we know that radius increases as we go down a group. So we would expect that lithium would have a smaller radius, but we would expect that cesium would have a larger radius. And in fact, since we also know that radius decreases as we go across, these would both have smaller radii than potassium. So 2 and 3 were both choice A, chlorine and cesium. Okay. And number 4 is just simply knowing your trends. As you go from group 1 towards group 18 across a period, what happens to atomic radius? It decreases. They get pulled in tighter. I think number 5 is probably one of the harder ones because you have to compare 4 different pairs. So we've got neon and carbon, and they're in the same period. We know that atomic radius shrinks as we go towards the noble gases. So neon would be the smaller atomic radius, so it's not A, it's not that pair. That's listed with the neon would have the smaller radius. For B, we have calcium and potassium. Well, again, we know that radius decreases as we go towards the noble gases. Calcium will be the smaller radius, and so it's not that pair, because we're looking for one that has the larger atomic radius first. Then we have bromine and fluorine. Well, we know that atomic radius increases as we go down a group. Bromine would be larger, and it's listed first. So that sure looks like our winner. And then if we look at barium and strontium, just to compare, strontium is listed first, but strontium would have the smaller radius. So those are kind of challenging because you have to really, compare each at a time. You can't just pop that off the top of your head. Okay, number 6. I had 2 people in the other class. I don't think I had anybody in here who really read that carefully, because I can tell you that the person who wrote the test didn't read it very carefully. The question reads, the measured distance between the nuclei of 2 bonded atoms is... Now what I meant the question to say was 1/2 the distance between the nuclei of 2 identical atoms which are bonded is, and then it would be atomic radius, which is what all of you put. However, the way the question's written, it actually refers to bond length, but we haven't talked about that yet. So, whoops. My bad, I need a proofreader. Okay, and that would be atomic radius. We won't start to talk about bond length until next chapter. Okay, so we're now on number 7. Describe the relationship between atomic radius and ionization energy. You can say something as simple as they are inversely related. They are inversely related. When one increases, the other decreases. That's a complete answer, because that question isn't asking why. The question is not asking why. Now, when we get to 8, explain why atomic radius tends to increase as you go down a group. So, to get the full 2 points for this, you had to do 2 things. If you just said, and a few people in each class said something like, it adds more electrons. So what? What does that mean? I don't know what that means. Tell me more. To get the full 2 points for that, you had to both say that as you add electrons, you add energy levels, and those energy levels take up additional space outside the nucleus. So, number 1, you had to say something about adding more energy levels. But the other thing you had to say was that as you add more energy levels, electron shielding starts to occur. And you could either have said the words electron shielding or described them. Ideally, you would say, as you add more electrons further from the nucleus, there are more energy levels in between the nucleus and those outer electrons. They can't pull on them as hard. This is called electron shielding. It tends to increase the radius. If you just said electron shielding, I don't know that you know what that means. Great, you can remember a vocabulary word, but it doesn't tell me that you get the concept. So to really do that well, you have to give some kind of description or explanation of electron shielding. So I'm just writing it here because I do know what it means, but you had to flesh that out a little bit. Okay? That's it. And overall, they were pretty good. A couple words in number 7, describe the relationship between atomic radius and ionization energy. I had some people say things like, when there's more energy, the radius is smaller. More energy what? More potential chemical energy? More gravitational energy? Are we perching atoms on hilltops? So you got to be careful with language. Questions, comments, concerns? You all email me with your FIP grade, your made-up points. You're exempted because you were absent. So, all right. With that.